Welcome to MS 100 lessons, and in this lesson I will be showing you how to interpret a line which is produced from one side of a shape in Euclidean geometry. So that is the learning outcome for the lesson, which is interpreting a line which is produced to a certain point. So for me to explain this, I will use two examples. And the first example is that of a triangle. Okay, so assuming we have a triangle APC, okay, and we want to have one side of the triangle to be produced to a certain point. So for example, let us start by producing BC, right? So if BC is produced to a certain point, then it means BC is continued. Okay, it is continued to a certain point. For example, if I have a line that extends from C to D, okay, so we say line BC has been produced to D, so it's a continuation. Now it continues from BCD, right? So BC has been produced, so it means one side of the triangle has been extended, right? And we want to see how do we actually interpret a line that is produced from one side of a triangle. So if one side is produced from a triangle, our interpretation is that we should have an exterior angle. Okay, we should have an exterior angle, and the exterior angle that I'm talking about from that line which is produced is this angle here, right, which is angle ACD. So this is the angle that I'm talking about, the exterior angle that I'm talking about. And this exterior angle, it must be equal to the opposite interior angle, the sum of the opposite interior angle. So it will be that angle plus that angle down there. Okay, so it means angle ACD is equal to angle BAC, which is that angle, plus angle ABC, which is angle down there. Okay, so every time you have a continuation of one side, or every time you have a line which is produced to a certain point, expect an exterior angle which is equal to the sum of the opposite interior angles in that triangle, right? So our conclusion in this, we can say angle ACD, which is this angle, is equal to angle BAC, which is that angle up there, plus angle ABC, which is that angle down there. And the reason for this is that we have an exterior angle of a triangle, right? And this is equal to the sum of the two opposite interior angles. So this is how we interpret a line which is produced from a triangle, right? So remember, any side of the triangle can be produced. If we have this triangle and that side of the triangle was produced, then our exterior angle is that angle over there. It should be equal to that angle plus this angle down there. Okay, so watch out for any line which is produced. So That is the first example, a line that was produced from one side of a triangle. Okay, so now for the second one, I want us to check a line which is produced from a cyclic quad, right? So let's say we have a cyclic quad like that one. So that is A, B, C, D, right? So provided that this is a cyclic quad and we want to produce one side of this cyclic quad to a certain point, maybe E. Okay, let us start by producing DC. So if we were to produce DC, then that would continue from C to E. So now we can say DC has been produced to E. So it's a continuation of that line, right? So if there's a continuation, you should expect an exterior angle also. That is the exterior angle that I'm talking about, okay? Which is BCE, angle BCE. And that exterior angle, it should be equal to the opposite interior angle, which is angle A up there, which is angle DAB, right? DAB, that angle in between. So these two should be equal if this is a cyclic quad, right? So now we can see that there is a continuation of a line. It means one side has been produced to a certain point. So expect an exterior angle. So we can conclude that angle BCE, right? That is equal to angle DAB, or angle A up there. And reason being, we have an exterior angle of a cyclic quad. Okay, so one side was produced, so expect an exterior angle. All right, so let us see some of the mistakes that learners usually make when it comes to these lines which are produced. Okay, so remember, even in this one we can produce that line. If we have produced AD to F, for example, our exterior angle would be that angle, right? And that angle would be equals to the opposite interior angle. Okay, so if you produce any side, just be aware of that exterior angle. So now I just want to check the mistakes that learners usually make when it comes to a line which is produced, okay, or when it comes to exterior angles. So usually you might have a triangle like that. Say you have a triangle like that, and there is a line that passes through that point, which is A, B, C, right? There is a line that passes through A, okay? And then now one would come and say, okay, if that is F, would come and say that that angle is equal to that plus that, okay? And this is wrong, because for you to have an exterior angle, one side must be produced to a certain point. It means there must be a continuation of a side, okay? So if you see that, you can see that AF is not a continuation of any side in the triangle, right? So this cannot be an exterior angle, right? But if you look at the example that we had up there, you can see that CD is a continuation of BC. It is a continuation of one of the sides on the triangle. So now you can have an exterior angle, okay? So just be careful that when you check an exterior angle, it must be a continuation of one side, okay? So that is wrong. And another mistake that learners make on a cyclic quad is that you might have a cyclic quad like that, right? And let's say that is A, B, C, D. And then you have a line passing maybe through D, for example, which is up until F. And then you might find a learner saying that, okay, I have an exterior angle here. So that exterior angle is equal to the opposite interior angle, right? This is wrong. Why? And that is because you can see that this line DF is not a continuation of one of the sides, so it cannot be an exterior angle. Okay, so that is not an exterior angle because it is not a line that is continuing from one of the sides, right? So for you to have an exterior angle in a cyclic quad, one of the sides must be a continuation, right? Okay, so let us have some practical examples from past papers. So if we can check this example one here, they say in the diagram below, AC and CE are tangents to the circle, okay, with center O. B, D, G, H are points on the circumference of the circle. So you can see that B, D, okay, G, and H, all these points are on the circumference. And when you join them, they give you a cyclic quad, okay? So when you join them, they give you a cyclic quad. So they say HG is produced to F, right? So there is a line which is produced. And you can see that HG is one of the side of the cyclic quad. So it means HG is continued to F. So this HG has been produced to F. So it's a continuation. So if there's a continuation of that of one side, then you must expect an exterior angle. So in this case, where is our exterior angle? You can see that from that line that has been continued or extended or produced, you can see that there is an exterior angle here, right? And that exterior angle must be equal to the opposite interior angle, okay? And that exterior is G2. So G2 is equal to B2 up there. And reason being, that is an exterior angle of a cyclic quad. Okay, it must be equal to the opposite interior angle. All right, so this is an example on how you interpret a line which is produced, right? So is there any line produced from a triangle, right? How many triangles do we have? We have C, B, D. Okay, we have this triangle up there. So in this triangle, is there any line which is produced? You can see that in CBD, you can see that BA is a continuation of CP. So one side has been produced, right? One side has been produced. So now let us interpret the extended angle for the triangle. Okay, so there are many triangles in this diagram, but I'm starting with this triangle here, which is CBD. Is there any angle which is produced, right? We just want to interpret the exterior angle of that triangle. So you can see that BA is produced from CP, right? BA is produced from CP. So this is a continuation. All right, so it means our exterior angle would be that angle between the line that has been continued, right? And this angle, which is B1 plus B2, right? It must be equal to that angle C plus that angle D, right? So it means angle ABD. We can write it as ABD, right? ABD, which is B1 plus B2. That should be equal to angle C up there plus angle D1. And reason being, that is an exterior angle of a triangle. Okay. And same thing would apply to the other side which has been produced, which is CD, right? CD has been produced to E. So there is a continuation here, right? So you should expect an exterior angle. That is our exterior angle, okay? And that exterior angle is equal to angle C plus B3, right? So it means angle, this is D1 plus, no, not D1, that is D2 plus D3 plus D4. That is equals to angle C plus B3. Reason being, exterior angle of a triangle, right? So that is the first triangle whereby we identified a line which is produced. So let us look at another triangle. So let us look at triangle BHD. Is there any line that is produced in this triangle? BH is not produced to anything, right? It starts here and it ends here. HD is not produced to anything, right? BD is not produced to anything. So we cannot have an exterior angle theorem on this one, right? So let us look at let us look for another triangle now. Maybe DHG, right? DHG, this triangle. Is there any line that is produced to a certain point in this case? So look at DH. DH is not produced to any point, right? Look at DG. DG is not produced to any point, right? But look at HG. HG continues to F. So HG is actually produced to F, right? So since it is produced, you should expect an exterior angle, right? So you can see that our exterior angle is G2, right? And that G2 should be equals to the opposite, the sum of the opposite angles, right? Which is D3 and H2. So you can say angle G2 is equal to D3 plus H2. Reason being exterior angle of a triangle. It should be equal to the sum of the two opposite interior angles. So that is how we interpret the lines which are produced in this case, right? Remember, I'm not answering any questions. I'm just interpreting what we have discussed so far for a line which is produced in a triangle and a line which is produced in a cyclic quad, right? And we have identified them in this example. So let us look at another example. So example number 2, right? We have this diagram here. Instruction says in the diagram below, A, B, C, D is a cyclic quad, right? So they tell you that A, B, C, D, that is a cyclic quad. And you should know all the properties of a cyclic quad, right? But now I'm focusing on the line which is produced to a certain point, right? So that we can conclude our exterior angle. So let's see. We have AB and DC are produced to meet at E, right? Where is AB? So from the diagram, you can see that that is AB. It is produced to E, right? So you can see that AB is one side of a cyclic quad, okay? And it is produced to E. The fact that there is a line which is produced and which is one of the sides, we can conclude that we have an exterior angle now. That is our exterior angle, B1. It should be equal to D2 up there, right? It should be equal to D2. All right, so P1 is equal to D2. Reason being, exterior angle of a cyclic quad. It should be equal to the opposite interior angle. Okay, so that is one theorem that we can identify from a line which is produced, because we have a cyclic quad here, right? But they also said DC also is produced to meet at E. Okay, so even this line, which is DC, is produced to meet at E. So the fact that it is produced, we can also have an exterior angle, and that is our exterior angle down there. Okay, that angle should be equal to the opposite interior angle up there. So this C1, angle C1 is equal to angle A up there. Okay, and angle A can also be written as BAD, okay, which is BAD, that angle in between there. Reason being, exterior angle of a cyclic quad. Right? So we have identified now the exterior angle from the two lines which are produced to meet at E. Okay? And then let us continue with the statement. They say AD and BC are produced to meet at F. So we also have other lines which are produced, but let's check. Are they produced from the cyclic quad that we're talking about? Okay, so let's see. AD. So AD, we have AD here, which is produced to meet at F, right? We do have an exterior angle. So that is our exterior angle. And that exterior angle is equal to the opposite interior angle up there. Okay, so now we can see that angle D1 also is equal to B2. Reason being, exterior angle of a cyclic quad, right? Okay, and then also BC is produced to meet at F also. So we also have another line which is produced, and that is the line which is produced there. BC is produced to F. Okay, so we do have an exterior angle here, and that angle is equal to the opposite interior angle, which is that angle up there. So now we can see that there is a relation between the exterior angles that we have obtained from the initial lines which were produced, right? You can see that angle A up there, which is that 3x, is equals to this C3, exterior angle of a cyclic quad, because there was a line produced, right? And you can also see that this same A, we have said it is equal to C1, right? So it means C1 and C3 are equal. And also they can be equal because they are vertically opposite angles, right? But that you can also see from the theorem that says an exterior angle of a cyclic quad is equal to the opposite interior. So now we can see that down here we have 3x. And also here we have 3x. Okay? So now we are done with our lines which are produced from that cyclic quad. Now we can also check whether there are lines which are produced in triangles, right? And how many triangles can we identify? We can identify at least two triangles, right? Which is E, B, C. Okay, we have EBC, that triangle over there. And you can see that in EBC, right? EP, that side EP, look at EP, it is continued to A. So it means EP has been produced to A, right? So let me just draw this structure this side. So we have something like that. We have E, B, C. It is produced to A, right? So if it is produced, then we expect that angle to be an exterior angle, and that should be equal to E plus C, right? So we can see that B2 is equal to angle E plus C1. Reason being exterior angle of a triangle, right? And you can see that angle E is x, which is given, right? And also C1, we have concluded that C1 is 3x. So it means B2 is equal to 4x, right? So you can see that that is 4x. And also remember, you have also concluded that if B2 is 4x, also D1 is 4x, right? Looking at the colors right, down there. So we have 4x even down there. Okay? So that was from a line which is produced on that triangle. But also in the same triangle, EBC, EC is produced to D, right? We have something like that to D. So that angle should be equal to that plus that. Okay? Which is C2. C2 is equal to B1 plus E, which is X up there. All right, so another triangle that we have CFD. Is there any side which is produced to a certain point? Looking at the line FD, FD is produced to A, okay? So if FD is produced to A, we should have an exterior angle D2, okay? That exterior angle D2 must be equal to that angle plus that angle down there. Okay, so it means let me just clear here. It means that angle D2 is equal to the sum of the two opposite, right, which is angle F down there plus C3. That was C3, okay? And angle F is given as 2x plus 3x. Therefore, that is 5x. So D2 is 5x, right? And remember, from the exterior angle of a cyclic quad, that should be also 5x, right? And another one that is produced from this triangle CFD, we can see that FC is produced to B, right? So that angle, which is C2, is equal to D1 plus F. Okay, so D1 is 4x and angle F is 2x. So that would be 6x, right? So in this case, we can also calculate the value of x using the triangles or using the cyclic quad. Remember, opposite angles of a cyclic quad are supplementary. Okay, so it means that 3x and that 6x must give you 180. So that is 3x plus 6x must give you 180. And remember, I'm not presenting, this is not how you should present your work when you're answering, right? You should first say angle A plus angle C2 is equal to 180. You write your reason to be opposite interior angles of a cyclic quad are supplementary. Okay, and then you say that angle A is 3x because it is given, and C2 in this case was calculated. Okay, and then you do that. So that would be 9x equals to 180, and then you divide by 9, and then you divide by 9, and then x would be equals to 20 degrees. Okay, and also you can calculate the value of x using a triangle, right? Because the sum of angles in the triangle should give you 180. I mean, yes, that should give you 180 because they're supplementary. So that would be 3x, okay, plus 4x plus 2x. That is equals to 180 because the sum of angles in the triangle are supplementary. So that would be 9x equals to 180, and that would still give you the same answer, right? X is equals to 20 degrees if you were to calculate the value of x, right? So you can see that most of our interpretations was from a line which was produced from a triangle or a line that was produced from a cyclic quad, right? So this is how we interpret a line which is produced. And remember the mistakes that learners usually make, try to avoid them. And thank you for the lesson.